Today, we are going to talk about various economic factors on stock prices. First of all, the data was obtained from Fred and Yahoo Finance, and its range is from September 2000 to December 2023. This is because some data are provided only after September 2000. So we started our title with stock prices, but we actually narrowed down to S&P 500 price since it is the most representative stock in the world. Each of us will deal with relationship between S&P 500 and macroeconomic factors, federal policies, livelihood factors, commodities, and best performing sectors. We share similar structure. First of all, our study is exploratory observational study. So we first build our model and begin some model selection with best subset algorithm, then remove outlier in the model, then go further diagnostics and remedial measures. Finally, do hypothesis tests. Now Ishita will begin her presentation.
So my research question is, how do macroeconomic factors impact the adjusted closing price of S&P 500 index? So my response variable is S&P 500 and predictor variables are GDP, inflation rate, interest rate, and industrial production manufacturing index, because these are the most macroeconomic factors. Okay, so my null hypothesis was that none of the macroeconomic factors have any significant impact on S&P 500, and my alternative hypothesis is at least one of the macroeconomic factors have a significant impact on S&P 500, and these are my reduced and full models. So I first started to see that do I require all the predictors? Are all the predictors important in the model? So I ran best subset algorithm, and it showed me result that all the predictors, all the predictors are important. As all the results show that these are the best values that for these all for four predictors. The model with the four predictors. This was my initial model with the raw data. Then I ran diagnostics and I found some multicollinearity issues and also a non-normal distribution of residuals issue and heteroscedasticity issues. So first I started with data cleaning. I removed the extreme outliers in Y and also the extreme influential points in X. So after cleaning the data, I saw that R square value increased and the standard residual error decreased, which is a good sign. Also, the normal the QQ plot looked a lot better, and the quantiles represented more normal distribution, especially at the tails. But it still didn't solve some issues like Anderson-Darling test failed and BP test failed. Uh, so there were heteroscedasticity and other issues. So I went for advanced remedial measures. So I applied WLS plus bootstrapping. This was the result, and it actually solved the issue of heteroscedasticity as p-value got became 1. And to solve the issue of multicollinearity, I went with ridge regression plus bootstrapping, and it solved the issue of multicollinearity. But the question is now which is the best model and which one should I go with? So the clean data, WLS, and ridge regression, I ran on these three models. I ran tenfold cross validation, and I found that WLS gave high. The lowest value of RMSE and highest value of adjusted R square. So I'll go with this model for my hypothesis testing. So this was just a reminder. This was my null hypothesis, and this was my alternative hypothesis. So I ran ANOVA, and I found F value to be very high, much more higher than F critical value. And as you can see, this P value is very significant. So I rejected the null hypothesis and concluded that at least one of the macroeconomic factors are significant. But question is which macroeconomic factors are significant now? So from this result, we can see that all of these macroeconomic factors are significant. After correcting for Bonferry multiple corrections, we still find that all of these predictors are important, are significant. Now, how do they impact the S&P 500? So, GDP and interest rate positively impact S&P 500, and inflation rate and industrial production manufacturing index negatively impact S&P 500 because their beta values are negative. So in these insights can help investors and policymakers in leveraging economic indicators to make informed decision and foster stable financial markets. Dash.
Our research explored the impact of federal policies on S&P 500 daily closing price using four key variables: inflation rate, interest rate, unemployment rate, and monetary aggregate, as you can see here. And the initial model achieved an adjusted R square of 0.91951, demonstrating a strong fit, but diagnostics revealed issues with normality and heteroscedasticity. To address these issues, we removed 853 outliers using Cook's distance, DFITs, DF betas, which improved the model's reliability. The clean model, as we can see here, R had a better R square. Also, uh, through the best subset selection process, we can confirm that all independent variables are important. We then applied several advanced statistical techniques like Box-Cox model and WLS squared model. So Box-Cox transformation with a lambda of 0.94, this transformation improved normality and reduced residual deviations. The WLS method, by squaring and adding variables and then applying WLS method, stabilized variance and explained additional variations. We also explored the interaction model WLS, but with high multicollinearity, we rejected that. And the next one was the robust regression model that we explored in the next slide. So this model minimized the influence of outliers and addressed the multicollinearity effectively with values under 5. So out of these models, we chose the best three models, as we can see in the summary slide, where the WIP values were under 5 for all these three models and had a higher R square and relatively lower residence channel error for a 10K cross validation. So using that method, the Box-Cox in the next slide, the Box-Cox model emerged has the best, offering the lowest RMSE and the highest adjusted R square, and the second highest adjusted R square. We also see that the AIC, BIC, press, and CP for this particular model is the lowest. And here the F statistics is 42,670, which is way more than F critical value. After the back transformation, here we can see the full equation. Now, going on to the hypothesis testing, confirms the model's significance with inflation rate and showing a strong positive effect and unemployment rate having a negative effect. Our work highlights that how federal policies shape market dynamics and provides practical insights for investors and policymakers.
Okay, I will do the next presentation. My name is Yifan Li, and the background of my study is that the macroeconomic indicators are a key area of the financial research. Furthermore, this study will focus on the livelihood indicators. And income is considered a very important variable based on the previous study. Previous study also shows that during the economic growth period, an increase in employment has positive consequence but a negative consequence in economic decline. The variables that represent the livelihood are the employment rate, oil price, consumer price index, and average hourly earnings. So the research question is how each other variables interact with the average hourly earnings. I will set up three hypotheses to check whether each coefficients of induction are zero to answer the questions. Based on my hypothesis, I will set up one full model and three reduced model like this. Before formal model building, I did the automatic modeling selection to check whether all variables can be resolved. Result shows that the model with all predictors and the inductions is the best model. Using the same method with other group mates to get rid of the 1000 odd layers, I got a better model using the decline clean data. Then I checked the non-volatility and multicollinearity using the QQ-plot and GWave. Results shows fair, because the scatters are going along with the lane and the GWave is not over 5. Then I checked the heteroscedasticity and the variable plots, and BP test shows strong heteroscedasticity. So using the weighted least square to solve this problem, we can see the result is better. Then I estimated more precious coefficients by bootstrapping. The coefficients here will be the final model. The k-fold validation shows the R squared and RMSE are slightly better after remedy. Result of GLT test show all tests should reject the null hypothesis. Based on the model coefficients, income has a strong positive effect, which is similar to the previous study, and employment has a negative effect. Hypothesis tests tell us that all interactions are significant, but interactions of oil price and CPI are too weak to be meaningful. Interaction between the employment rate and average hour learning tell us that higher employment during the economic upturn will mitigate the negative impact of the employment itself on stock price. And higher employment during the economic downturn will slightly stabilize the market. In conclusion, we give a more precise description of the previous studies on the economic upturn part, that the positive consequences are mitigated effect of interaction. On the economic downturn part, obviously, higher employment will cause a decrease in stock price, which is also aligned with research 3. The result highlights we need to address the employment as a critical issue. Solving the employment problem directly would improve both economic environment and individual lives. Thank you.
Hi, my name is Vedant, and I'll be presenting our next research question, which checks whether commodity prices have an equivalent effect on the S&P 500 adjusted close price. Historically, commodities have shown complex relationships with equity markets. Oil reflects economic health, gold and silver act as safe haven assets, and copper signals industrial activity. Understanding these dynamics is crucial for analyzing their impact on the S&P 500. We first began by removing 185 significant outliers using diagnostics like Cook's distance, DF betas, and DFITs. Next, we ran a best subsets regression, which helped us identify that all 4 of our model predictors, namely oil price, gold price, silver price, and copper price, were important to our model. We also identified that removing outliers addressed leverage issues and slightly improved residual normality and stabilized the model. However, despite cleaning the data, we observed that multicollinearity, normal residuals, and heteroscedasticity issues persisted, as could be seen by the results of the Anderson-Darling test and Bruce-Wagen test. To address these, we applied 3 different remedial procedures. First was a weighted least squares to manage heteroscedasticity. Next, we had a Box-Cox transformation on the clean model to account for non-normality and variance stabilization. And finally, we had the WLS, again, after transformation to refine the model fit. The WLS model on the clean data improved adjusted R-square and residual standard error, but didn't fully resolve normality or heteroscedasticity issues. The Box-Cox transformation improved residuals slightly, but underperformed as compared to the WLS model in explanatory power. Post-transformation WLS showed no further improvement in terms of key metrics, with a slight increase in multicollinearity. When it came to model selection, we went ahead with the WLS pre-transformation model due to its lowest AIC and SBC values and having the highest adjusted R-square and R-squared values as compared to the other values, and it also had the second lowest RMSE and MAE values. And next, we ran bootstrapping to confirm the reliability of the coefficients that we obtained from our WLS pre-transformation model. To do so, we generated 95% confidence intervals for each of our coefficients. And finally, for a hypothesis test, we conducted a general linear hypothesis test to answer our research question, which essentially was the null hypothesis, which checked if commodity prices have an equivalent effect on the percentage change in S&P 500 adjusted close price.
And our alternative hypothesis was that at least one of these commodity prices had a different effect from the others. From the results of our hypothesis test, we were able to reach the conclusion that we had sufficient evidence to reject a null hypothesis claim. That is, we were able to identify that at least one commodity price had a different effect on the S&P 500 adjusted close price as compared to the others. Our findings show that commodities impact the S&P 500 distinctly. This insight helps investors and policymakers make informed decisions during economic shifts or periods of market uncertainty. Thank you.
So hi, my name is Andy, and my research question is, does the best performing sector in the stock market and its related raw material have a different interaction effect on S&P 500 price compared to an unrelated raw material? So for example, energy and technology sectors are closely related with copper, but not with gold. I wanted to investigate whether the interaction between sectors and different raw materials is significantly different. Here, X5 is the best performing sector of a day, which is a categorical variable. So it is 1 if the best performing sector is energy or technology, otherwise 0. My initial model has 3 single terms and 2 interaction terms. Note that the 2 interaction terms are necessary for hypothesis tests. I wanted to check if I can drop out any of 3 single terms for model simplicity. However, the best subset algorithm says every terms are important, so I go with the initial model. Here are the diagnostics procedure. First, I remove 722 outliers. Second, I confirm that the multi-core linearity is not a big issue. Then I face the normality and heteroscedasticity issue. So my possible options are Box-Cox transformation or a WLS model. I noticed that there are 2 types of Box-Cox transformation. Left one is the one we learned in the class. The right one is not what we learned in the class, but still is very popular. So I tested with both types, and surprisingly, they showed the same diagnostics results. Here you can see the exact same shapes of QQ plots and residual plots. And then I proceeded with WLS. As a result, AD test says Box-Cox and WLS didn't resolve the normality issue. BP test says only WLS solved the heteroscedasticity issue, but not Box-Cox. However, as you can see here, to me, it seems that Box-Cox transformation solved the heteroscedasticity issue better, so I decided to put both into model validation step. As a result of tenfold cross-validation, the Box-Cox transformation showed the best. Thus, my final full model looks like this, and since I'm interested in only interaction terms, they have these confidence intervals after Bonferroni multiple comparison correction. You may notice that the confidence intervals doesn't overlap. So next, I performed hypothesis tests. My null hypothesis, the interaction effects are the same, and alternative hypothesis is no, they are not the same. I ran GLT tests, and it says there are indeed different interaction effects. In other words, when copper price change, the technology and energy sector's performance can be directly impacted, which in turn affects the S&P 500 price, and this interaction is significantly different than gold. Now we showed that they are different. In the future, we can investigate whether the effect is stronger, for example, by directly comparing the beta values with normalized or scaled variables. So this is all for our presentation. Thank you for watching, and I'd like to also thank the professor and the TAs for helping us.